Hey everyone, welcome back to Age and Education channel. Today again we shall continue with the chapter Light. So what are all the topics that we have covered till now? Just as a recap, it is important that you refresh your progress, okay? It is very important. Only then you can understand, you can link up the things, okay? So what all have we covered? We have covered about the laws of reflection, right? And for this, what all the things that we have seen, we saw about incident ray, reflected ray, normal to the point of incidence, right? And angle of incidence and angle of reflection. Okay, and we know these have to be in the same plane is the first law, and these both should be equal is the second law. Okay, and after that we have seen the differences between the real image and virtual image, right? And based on this concept we have cleared the concept of formation of images by a plane mirror, right? So we have seen how what helps the mirror to reflect the light. It is what is it called as silvering, and in silvering what are the things that will be used? Yes, it may be silver or aluminium. Okay, and what will be the characteristics of the images formed by a plane mirror? Okay, invariably it will be first what can you say? It will be virtual, and if it is virtual it will have to be erect, and the size will be same, right? The distance will be same, and the most important thing is you can see lateral inversion. Okay, so this is about the plane mirrors. Now tell me, how about the spherical mirrors? Okay, as I have mentioned earlier, we will now look into spherical mirrors. That is, you can say it to be like a concave mirror or convex mirror. Okay, now let us see what are these types of mirrors and what are the properties and how the images are formed, and there will be many concepts like pole, center of curvature, principal axis, principal focus, focal length, and we will see about all these now. Okay, so buckle up. Fine. Okay, so about the spherical mirror. So what is a sphere? What is the meaning of sphere? Sphere means you all know that it is a 3D form of circle. Yes, so to get the spherical mirrors, what do you call, if you imagine you cut any circle, what you get? You get one surface like this, right? And another surface like this. Okay, so if you take this and here you take this one. Okay, so if you gray this part out, and here also you gray this part out. Okay, now what happens? This surface, it is bulging outwards, right? So this type of mirror is called as what? Convex mirror. Okay, a mirror that bulges outside is called as convex mirror, and a mirror that what do you call, not bulges, that will be inward. Okay, so it means that it is curved inwards. What is it? It is curved inwards. So inward curving mirror is called as what? Concave mirror. Okay, so don't get confused. This part, okay, what do you call the here? All the incident rays will be here. Okay, when the incident rays are here and here all the silvering happens, then it is called as what? Yes, it is convex mirror. Okay, now if you take a mirror of this sort, okay, and here all it has been silvered and all the rays will fall here, okay, and will be reflected by this surface, then it is called as what? Concave mirror. Okay, so it is curved inwards and this is bulged outwards. What is it? Bulged outwards. Okay, it is important to remember this one. Okay, if it is like this, if the mirror is curved inwards, it is called concave, and if it is curved outwards, it is called as what is it? Convex mirror. Okay, so if you can see, both of this form a part of a sphere, right? So we call it as spherical mirrors. Okay, now here you will have to understand some things here, so that what happens is you will have to check, you will have to understand that there are so many possibilities of the formation of image. It is that in the same mirror itself you can see at one point you can find an erect image, another point you can find inverted image, or at one point you can see real image and other point you can see virtual image. Okay, so to understand all this, at what point what happens, where, at what point if you put an object, what sort of image you get out. Okay, for all this you will have to understand some terms. Okay, now let us look into those terms. These are very important. Okay, so the center of the any mirror that you take. Okay, what is it? The center of the first, let us see about this mirror. Okay, what is this mirror called as? Yes, convex mirror. Okay, now the center of the mirror is what? It's called as pole. What is it? Pole. This part is pole. Okay, now see, you can easily understand that it is a part of the sphere, right? It is, this convex mirror is part of this sphere. So you can easily know what is the center of the sphere, right? So this center of the sphere is called as what? Center of curvature. What is it? Center of curvature. So what next? Join these two. Sorry, my line is going somewhere else. Okay, so this is called as radius of curvature, and a line passing through the center of the curvature and the pole, this is called as what? Principal axis of the mirror. Okay, what is it? This one, this whole one is called as principal axis of the mirror. Okay, it may extend this side and that side. Okay, there is no limit to it. Okay, whereas radius is this part. Okay, but the principal axis is, it may extend all through, but the only thing is that it should connect the pole to the center of the curvature. Okay, now you know about what? You know about the pole, which is the center of the mirror, and the center of the sphere is called as center of the curvature, and the line joining pole and the center of curvature is called as the principal axis of the mirror. Okay, now you have this, right? So the midpoint of the pole and the center of curvature is called as what? Principal focus. What is it? It is called as principal focus. Principal focus, and it can be termed as F. Okay, so now you know about principal focus too, right? And the other thing that you have to understand is that there is also something called as focal length. What is this focal length? It is the distance between the pole and the principal focus. Okay, what is it? It is the distance between the pole and principal focus. It is called as what? Focal length. Okay, so as you know, this principal focus is the midpoint of these two, right? So if this is principal, this is the focal length F, and then this will also be F. So the distance between the pole and the center of curvature would be 2 times the focal length, right? I hope you all understood this. I'll repeat this again so that you can easily remember everything. Okay, as I have mentioned, just take like this. What have we considered? We took the convex mirror, right? In the same manner, I will explain about the concave mirror too. Just don't worry about it. Okay, for now you understand the terms, because the terms will be same in even if it is a concave mirror. Of here, the center is called as what? Pole. Okay, pole P. Now, as I have mentioned earlier, if you make this part of the sphere, here, the center of the sphere, the circle rather. Okay, the center of the circle will be what? Tell me, center of curvature. Okay, center of curvature. And the line, the radius of this circle is called as what? What is it? Remember, radius of curvature. Right, radius of curvature. Now, apart from this, what we have seen, we also know that this line, the line joining the pole and center of curvature, is called as what? Yes, tell me, I am waiting. Yes, it is the principal axis of the mirror. What is it? Principal axis of the mirror. Now, the midpoint of the pole and the center of curvature, what is it? It is called as principal focus. What is it? Principal focus. Okay, and what is this length called as? The length between pole and principal focus is called as focal length, right? Focal length f, and so this will be 2f. Now, in the similar terms, we will see about all these in a concave mirror too. Okay, so how will the concave mirror be? You all know that it will be like this, right? So all the rays, where is the surface onto which the rays will be incident? Here, this way, right? This is the surface that we want, that we are interested in, right? So now let us see about all these. What are all the things that we have mentioned earlier? We want a pole, we want to know where the pole will be, and how about the center of curvature, okay, and radius of curvature. What else? Radius of curvature and principal axis. What else? Principal focus. It will be the midpoint, right? So principal focus and focal length. Okay, so we will look into all these. We will specify as on concave mirror. What is this mirror? Concave mirror. On the concave mirror, where we can find all these. Okay, and I am repeating it again and again that this chapter you will have to be very careful. You should understand all the terms, because as you get into the things, it will tend to become more complex. Until and unless your basics are clear, you'll get confused. Okay, and you are now only in 7th grade. Okay, so when you get to higher grades, the complexity of all these concepts increases, and for you to understand everything in a proper manner such that it sits in your brain forever, you will have to understand the concepts in a very clear manner. That is the very reason I am repeating again and again, and I know that the number of videos for light will be it may go till 7, 8 or 10 too. Okay, I am not sure of it, but I want everything to be clear. Okay, now concave mirror. Okay, let us not waste any time now. Okay, what is this? This is pole, right? And now mark a circle. You can't go make a circle this side, right? It is so obvious that the circle should come here. Okay, and mark the center of it. What will it be called? Center of curvature. What is it? Center of curvature. So you have marked center of curvature too. Pole is done, center of curvature, and when you join these two, it is called as radius of curvature, right? So this one is also done. Now when you have a line joining the center of curvature and the pole, it will be called as what? Principal axis, right? So easy. Now how about the principal focus? The midpoint of pole and center of curvature is called as what? Principal focus f. Okay, and what will be the distance? What is the focal length? The distance between the pole and principal focus. This is called as what? Focal length f. So if this is f, this will be 2f, right? 2 into focal length. Okay, so these are all about the things in the concave mirror too. So we are done with all these, right? Now we will look into some other concepts now. Okay, now we shall look into the concept of converging mirror, and also after this we will look into diverging mirror. Okay, so what about this converging mirror and diverging mirror? Till now we have looked into concave mirror and convex mirror, and again now here I have come up with converging mirror and diverging mirror. Okay, nothing to worry, everything will be sorted out. Okay, so when the light rays are coming, they come parallel, right? So when the light rays are coming from some distant objects, the light rays will always come in a parallel manner. And when these fall on a concave mirror, what happens? When these fall on a, this is the concave mirror, right? So when these fall on a concave mirror, they get reflected, that you know, right? So how will they get reflected? They get reflected in a way that once they get incident upon the mirror, they reflect back and they converge at a point. Okay, so all the reflected rays will converge at a point. This image that I am talking about, you have already seen while I have explained about the real image and the virtual image. The same thing goes good here. Okay, so this is the concave mirror, and here comes what? The rays, right? As I have mentioned, all these will be parallel. Okay, when these are parallel, what happens? They come back, right? And while they are coming back, they converge at a point. It means that they meet at a point. See, all are meeting at this point. And what is this point called? It is called as what? Yes, principal focus. That is the reason we have learnt about all these in this illustration. Okay, so here what is it? Principal focus. So we know principal focus, right? And we obviously know what is it? Pole. Pole, the notation is P. Okay, for the principal focus the notation will be what? F. Okay, and the distance between the pole and the principal focus is, you all know, it is what? Focal length. Okay, so here what happens? For the concave mirror, you find the incident rays after they get incident, and when they get reflected back, then they converge at a point. Okay, and so we call these mirrors as converging mirrors. So when someone asks you what are converging mirrors, you can say that the concave mirrors are the converging mirrors. Okay, in the same manner we will see about the diverging mirrors too. Okay, this one, tell me what sort of image you can find with this thing. You can just recall what I have mentioned here. There is a real converging point. When there is a real converging point, what you get is real image, right? Okay, now let us get into convex mirror. Let us see how we get how it is called as a diverging mirror. Okay, so now take what mirror? We have seen about concave mirror. Now let us see about the convex mirror, right? So as such, first of all, you know what is this? Yes, pole, P, right? Now we have to understand where you get the focus, principal focus, right? So first of all, as I have mentioned, the light rays will always be parallel to each other when they are coming from a distant object. Okay, so they come like this, and what happens? They reflect, right? They get reflected back. And how will this reflection be? You will see that these reflected rays will be diverging. It means that when you extend all these, okay, when you extend all this, you can see that they appear to converge at a point that is not real. Okay, so this imaginary point of convergence can be called as principal focus here. Okay, so this point of convergence is not real. Here these rays, these incident rays, when they are reflected, these reflected rays are not converging, they are diverging as such. So when you go back and see the point of convergence. Okay, these appear like they are being reflected back from a point. Okay, so they are all coming from a point, they are appearing. So this is not true. So when it is not true, what sort of image? Yes, virtual image, right? So now this point is the principal focus, and this distance is called as what? Focal length. Okay, so here as the reflected rays are diverging, this sort of mirror is called as diverging mirror. Okay, so what is diverging mirror? Where can you find it? What is it called as? It's called as convex mirror. Okay, convex mirrors are the diverging mirrors, and concave mirrors are what? Concave mirrors are converging mirrors, right? And how about the convex mirrors? You can call them to be diverging mirrors. Okay, it is as simple as it. Just don't worry about it. And later we will look into the image formed by a concave mirror and image formed by a convex mirror, and there will be so many things to learn here. Okay, and I can't continue further because you will have attention deficit, and I don't want all that. First you ingrain all the knowledge that you have got till now. Okay, repeat the video if you want again. Let me get back like in the next video. I'll tell you about the images found by concave mirror and convex mirror. Maybe that like it will take around 15 to 20 minutes. Okay, later on we can see about the refraction of light and everything else. Okay, bye, see you for now.